Okay, so let's try some of these where the picture's not already drawn for us. So it's cosine 270. I'm like, oh, I know where 270 is on the unit circle. That's my quadrantal angle down here. I know my coordinates are 0, -1. So what do they want? They want the cosine, and I'm thinking cosine. I know x is my cosine value when I'm on the unit circle with a radius of 1, and y is my sine value. So I'm thinking cosine theta, sine theta. So they want the cosine. That's just my x coordinate. That's 0. So the cosine of 270 is 0. Okay, what about the sine of 0? That's also a quadrantal angle. So that's in standard position right here. I know my coordinates are 1, comma 0. This time they want the sine. Sine is my y value on the unit circle. So I'm going to grab the y value, and the sine of 0 is 0. Reciprocal function. So remember, cotangent is the reciprocal of tangent, so it's x over y. I'm thinking about where 7 pi over 4 is on the unit circle. 7 pi over 4 is in fourth quadrant. We love our denominators of 4 because that makes the coordinates easy to remember. They're both root 2 over 2 and root 2 over 2. But because we're in quadrant 4, our x is positive and our y is negative because we're coming forward and down. So once I know what those coordinates are, I'm just going to drop them in. The x coordinate is root 2 over 2. The y coordinate is negative root 2 over 2. Anything over itself simplifies to 1. The negative is still there, so that's -1. So the cotangent of 7 pi over 4 is -1. Now let's try cosecant of 2 pi over 3. Cosecant of 2 pi over 3, so I'm thinking about 2 pi over 3. I'm right here on the unit circle. I know my coordinates there are -1/2 root 3 over 2. Because my x is negative in quadrant 2. My y is positive. So cosecant is the reciprocal of sine. Remember, every s needs a c. So cosecant is the reciprocal of the one that starts with an s. So it's the reciprocal of sine. So there's two ways to do this. We can remember we're on the unit circle. So cosecant is going to be r over y. And we know that our radius is 1 on the unit circle, and our y value is root 3 over 2. So you can think of it like that. And then you would have to divide by a fraction, you multiply by the reciprocal. So the faster way to do it is going to be to just think of it as the reciprocal or the flip of the fraction. So we can do it that way, but my preferred way to do it is just grab the fraction for sine, root 3 over 2, and flip it to 2 over root 3. Okay, now we still need to rationalize that denominator. So whatever's under the radical in the denominator, that's what we're going to multiply by. What we do to the denominator, we'll do to the numerator. So I'll multiply by root 3 over root 3 so that I'm really just multiplying by 1. Anything over itself is 1. So I'm going to change its appearance but not its value. That's going to give me 2 root 3 over 3. Okay, so our cosecant at 2 pi over 3 is 2 root 3 over 3. And you're going to see some of these numbers start to look really familiar because we've got the same x and y values just switched in position, sometimes positive, sometimes negative. And so the trig values we're going to get are going to be the same, only sometimes positive, sometimes negative as we're in different positions. So let's try some more. Now I do want to finish showing that other way on that one first. If we did it as r over y, so we had the 1 over root 3 over 2. Then to divide by a fraction, we multiply by its reciprocal. So we'd multiply by 2 over root 3. I would mark that out. And so 1 times 2 over root 3 is just 2 over root 3. And then we're in the same position we were here, where we just have to rationalize that denominator by multiplying by root 3 over root 3. And so we would still get 2 root 3 over 3. Either way you thought of it as r over y, or just remembering the reciprocal is the flip of the fraction. So if we know what the sine value is, root 3 over 2, we can just flip it to get cosecant. Either way works. Both ways will give you the same correct answer. All right, let's try another problem. So cosecant 225, okay, I'm thinking 225, that's in third quadrant with when it ends in a 5, that's my 45-degree reference angles where they're both root 2 over 2. And we know everything is negative in quadrant 3, so those are both negative. X and Y are both negative. Okay, so they want cosecant. Cosecant we were just talking about is the reciprocal of sine, because every s needs a c, so that's reciprocal of sine. So sine is the y coordinate, so I'm going to grab it and flip it. So that's going to be negative 2 over root 2. I flipped the fraction because it's the reciprocal function. Okay, now I just need to rationalize that denominator, so I'm going to multiply by whatever's under the radical in the denominator. What I do to the denominator, I've got to do to the numerator. That's going to give me negative 2 root 2 over root 2 times root 2 is square root of 4, which is 2. Are we finished? No, because 2 over 2 cancels, so I get negative root 2 is the final answer, negative root 2. Remember, when you're simplifying fractions, numbers in front of the radical can simplify and numbers under the radical can simplify. So here we had two 2's that were both not under the radical, so those simplified, but they did not cancel with the one under the radical. Okay. All right, so let's try sine of 300. So I'm thinking 300, I know that that's right here on the unit circle. So my coordinates there are 1/2 and negative root 3 over 2. They want the sine value. Sine is our y value on the unit circle. So it's just the negative root 3 over 2. Final answer. Can you see how fast it is when you have your unit circle memorized or can quickly generate it? All right, let's think about cosecant of 90. That's a quadrantal angle. I know my coordinates there are 0, 1. Okay, so cosecant's the reciprocal of sine. So my sine is my y value, 1 over 1. If I flip it, do the reciprocal to get the cosecant, it still looks like 1 over 1, which is still 1. Okay, tangent of 240. Tangent we know is y over x. So I've got to think about what my coordinates are at 240. Now, I know you got your unit circle handy, so I know you're tempted to just look at it, but I still like to think about it and generate it because you won't have it with you when you're taking the quiz. Okay, so at 240, I know my coordinates are negative 1/2 and negative root 3 over 2. Everything's negative in third quadrant. X is negative, y is negative. So tangent y is going to be negative root 3 over 2, and x is negative 1/2. Negative over negative cancels. When the denominators are the same, they cancel. That gives me positive root 3 over 1. If my denominator is 1, I don't have to write it. So tangent of 240 is square root of 3. What about sine of pi over 4? Pi over 4 is right there in first quadrant. We love the denominator of 4 because we know both coordinates are root 2 over 2 and root 2 over 2. Sine is the y coordinate, so we know it's just root 2 over 2. We don't even have to stress and think which one's x and which one's y because the denominator of 4, both coordinates are root 2 over 2. So if we want the sine, we just grab it. Tangent 120, so I'm like 120, that's just into quadrant 2. I know when I'm closest to the y-axis, my x-coordinate is 1/2 and my y-coordinate is root 3 over 2. But because we're in quadrant 2, x's are negative and y's are positive because we're going backwards and up to get into quadrant 2. Okay, what do they want here? They want tangent. We said we know tangent is y over x. So my y value is root 3 over 2. My x value is 1/2. Now we just want to simplify our fraction. When the denominators are the same, they cancel. That gives me root 3 over 1. If my denominator is 1, I don't have to write it. So the tangent of 120 is root 3. Now notice we said tangent of 240 was root 3 and tangent of 120 is root 3. That's what I mean about we'll have the same trig values in different locations for different angles. All right, let's try a couple more. Now this is where I'm going to get to use some of my favorite tricks to show you. We want tangent of negative 13 pi over 6. Now we can use the conversions that we did on day 1 of the unit to change, to find coterminal angles. Or to convert between radians and degrees. A fast way to do this though is we know that, so let me do this as a little aside workup here. Negative 13 pi over 6 is just negative 13 times pi over 6. Well, we know what pi over 6 is. Pi over 6 is 30 degrees. So that's just negative 13 times 30 degrees. That'll be a lot faster way to convert it than rather than converting it to degrees and then doing all of that. So that's a faster way to convert if you can think of it that way. So negative 13 times 30 It's going to be negative 390 degrees. Okay, so if we're thinking about where we are on the unit circle, you've got two different ways to do this. You can find the lowest positive coterminal angle, and we can do that by adding 360 to it each time. So we can do that. We can add 360 to that, and we get negative 30 degrees. Okay, and that's still not positive. So we could either think about going negative 30 and where that would put us on the unit circle, or we can add 360 to that again. So negative 30 plus 360 again gets us 330. And so sure enough, that's where we're at. We're at 330 on the unit circle. 330 is coterminal with negative 30, which is coterminal with negative 13 pi over 6. Coterminal angles have the same trig values. That's why we like them. So either way, when we want to find the trig value of negative 13 pi over 6, the first question is where is it on the unit circle? So this is how I converted it to think of it as degrees to then see where it was on the unit circle. I could have also, and what I really do love to do, this is the way I usually do it too, but I've got lots of different tricks or approaches. I'll let you pick which one you like best. I could have just thought when the denominator is 6, I could have thought of what a whole pi looks like with a denominator of 6. So what I mean is, what does a whole pi look like with a denominator of 6? It looks like 6 pi over 6. So if we're going negative, we're counting backwards. So if I go backwards half a circle, I've gone backwards negative 6 pi over 6. Another half circle gets me negative 12 pi over 6. And I just have to go pi over 6 further in the negative direction to get that angle. So for me, if I can take a minute to think about and count it as a fraction visually, then I don't have to do any of the mathematical conversions. It still takes a second thinking of counting it backwards. Let's see that again. So it's negative 6 pi over 6, negative 12 pi over 6, and one more pi over 6 in the negative direction gets me there. Either way, that lets me know where I'm at. I'm at the same location on the unit circle, and that's going to dictate what my x and y coordinates are to help me find the trig value. So do it any way you like. All right, so here I am. I'm pi over 6 away from 2 pi, so that means I'm at 11 pi over 6 is what it's coterminal with if you stayed in radians. And so I know that my coordinates there on the unit circle are going to be the root 3 over 2 for x and 1/2 for y. And I'm in quadrant 3, so I'm coming forward and down. So my x is positive and my y is negative. We know that tangent is y over x. So that tangent is going to be negative 1/2 over root 3 over 2. So when the denominators are the same, they cancel. That gives me negative 1 over root 3. If I have a radical in the denominator, I want to rationalize it. So I'm going to multiply that by root 3 over root 3. Now, some of you are going to be getting really good at rationalizing really quick, and so you'll be able to do that in your head. If you can do it in your head, you don't have to write it, but otherwise, go ahead and write it out. That's negative root 3 for the numerator. Root 3 times root 3 is the square root of 9, which is 3. That gets that out of the radical, and we knew it would. That's why we did it. And so my tangent of negative 13 pi over 6 is negative root 3 over 3. Okay, let's try another one. Okay, so it's negative 630. So rather than trying to draw that visually, I'm just going to find the coterminal angle. So we find coterminal angles by adding and subtracting 360. So I'm going to add 360. So if I just borrow from that 5, we've got more negatives. That's going to give me negative 270. It's still negative, so I'm going to add 360 again because we want the lowest positive coterminal angle so we can find it on the unit circle. So I'll add 360 again. Gives me 90 degrees. So negative 630 is actually coterminal with 90. So if I want the cosine of negative 630, it's going to be the same as the cosine of 90 because coterminal angles have the same trig values. So I'm going to think about 90 degrees on the unit circle. Cosine is the x-coordinate. I know the x-coordinate there, the coordinates are 0, 1, so the x-coordinate is 0. So that's just 0.